Okay, so now I'm going to walk you a little bit through the backend, which is composed basically of a Firebase application that you can see here with the users, information on the users with affinity with each restaurant. So basically, you see here we have the users, and for each user, we have scores with each restaurant, a set of score um, and basically data on the restaurants themselves in order to, so this is data which is duplicated with this table in restaurants in order to accelerate the queries when we do the query from the React app, and data on the users as well uh, to ease the display part. We have also affinities between users themselves, because in order to recommend users to other users as friend, or in order to get a better recommendation to the user, we compute also an affinity score between the users, and then data on the restaurants and a few reference lists, basically the different types of ambience we can have, like business, between friends, cozy, stuff like that. The different search criterias that we had, like quality, quantity, whether it is calm or not, the cleanliness, whether it is kids friendly, and so on, and the list of standard dishes that are present in the restaurants. So the dishes are standardized. So we use a web crawler to get the dishes from the restaurants, and then we mapped the specific dishes to a standard list of dishes. So this was done manually with expert knowledge. And then we have types of restaurant like Italian, French, etc. So we have this Firebase app, which is serving as well the React app as the backend that I'm going to show you now, which is running on instances in Google, and I'm going to SSH into the one of these instances to show you what's inside. So I'm going to SSH with the option X and C in order to be able to show you to open PyCharm in the VM from a distance and have the graphical interface directly on my computer. So I'm starting. So right now I am in the VM, and I am opening PyCharm in the VM. Um, should not take too long. So basically here it is saying that C locale, so I should be viewing the PyCharm interface directly on my computer. And basically this VM, the role of this VM was to compute on a daily basis automatically, so using a cron job, the user affinities, so to refresh those affinities based on the new data that we receive every day. And also in case we have new restaurants and new comments, to recompute all the affinities, because basically this is a kind of a recommender, like a recommending app. So to recommend in a personal way to each user the best restaurants for them, and we need to keep those recommendations refreshed. So by having relevant scores every time the user opens their app. So here you can see basically the structure of the repo. So I tried to stick to a clean architecture. So it was not strictly clean architecture, but I tried to get close to it with adapters here, which are basically abstract classes that I'm calling from infrastructure-based files. I have here my entities, so which are the restaurants, the user, the zone. So why do I use zones? Because we had like quite a few restaurants, a few thousands, and for the display, we cannot like send from Firebase all the restaurant at the same time to the React app. So when the user opens its app, depending on where the user is geographically, so it will belong to a zone and neighboring zones, and the app, the React app, we only query the data for this specific zone and the surrounding zones, so that as the user moves on, um, basically the transactions with the database are as minimal as possible to make the user experience better. So which is why we split made basically the map into different zones. And yeah, we have the users, the restaurants, and we have an affinity object that we are going to use. So an affinity object is basically um, a user, a restaurant, and an affinity level, so a score. So then we have a few libraries to interact with our Firebase database, to listen to this Firebase database and be able to export stuff in this Firebase database. And we have then fixed static files that are also can be also refreshed, and restaurant similarities that are basically pushed to this Firebase database. So in the use case, so each day, as I was saying, we are computing user restaurant affinity, a user affinity, and storing them in a Firebase or in a CSV. It was depending on the version of our application. We started storing it in the CSV, and then later on in Firebase. Here we can build the zones, we can fill the zones. So we build the zone geographically, and then we fill them with the data. So I'm not going to go through the zones because this is not what's interesting here. What I want to show you is how I am building the user restaurant affinity. So basically, I chose to base it on a TF-IDF approach, and then using a cosine similarity with, so basically we will have a big vector for each restaurant and a corresponding vector for each user. And in this vector, you will have features like um, the dishes which are served or not in this restaurant, how good those dishes are. So very good, average, bad. Then the ambience that we saw just before, the criterias, whether it is clean or not, whether it is calm or not, um, and the type of restaurant. So we have these features for the restaurant, and we have the exact same features for the user. So because when the user arrives on the app, he can fill in a profile containing their best dishes, their favorite ambiance, their favorite, um, their most important criteria in a restaurant, their favorite restaurant types. And if they don't fill it, you can see here, I am building a median user profile as a default for a user who would come on the app and not registering from the start, in order to have, at least from the start, some relevant information. So to build the vector for the restaurants, so here you can see build restaurant features for cosine. I use a TF-IDF approach, so term frequency, inverse document frequency, in order to make to make the most relevant features of a restaurant stand out. So this method is mostly used for NLP, but I applied it here because I found it was very relevant for this task of recommendation. So basically, I start by getting all my dishes and their correspondent to the standard dishes that I filled manually. And then my first set of feature is built, which is whether a specific dish is served or not in a restaurant. So basically, for each restaurant, I built a list of 10 dishes which are served. So the 10 main dishes in this restaurant, and if in all the dishes that we have in the database, if a dish is served in a specific restaurant, you would have a 1 or 0 if it is not served. But then that's not enough to know if it is served or not in a restaurant. When you are going in a restaurant, you want to order dishes which are good. So here I add a second set of features, which is for those dishes which are served, are they exceptional, good, average, or bad? And this is coming from the comments of the users. So for the beginning, um, I used Workforce to annotate a set of comments coming from each restaurant. And the idea before basically I stopped this project was to use NLP basically to extract those classes. I didn't I didn't get there. So here basically, so where you have a score for each category. And then you have the same for the criteria. So basically, for the level of the dish, so exceptional, good, etc., the criteria and the ambience, um, we consider like a set of 30 comments, and based on those 30 comments, if 10 people say that it is exceptional, the score of exceptional would be 10. If 20 people say in the criteria that it is calm, so the score of calm will be 10. If 5 say it is not calm, the score of not calm will be 5. And basically um, each feature, each sub-feature has a score. Same for the ambiance. So in ambiance, we have business, cozy, romantic, and basically you have the number of people out of the 30 people, the number of people who voted for this ambiance. And then I build the TF-IDF vector. So having here, so the corpus size is the number of restaurants I have in my database. And then for each of the features, so for each of the column, um, so this is vectorized code. If it is present, it's a 1 or it's a 0. Um, and then to compute the IDF, I take the corpus size times the inverse of whether it is present or not. So basically, it's to make the terms which are the more uh, common, the more frequent a term would be. So the less like if all the restaurants are calm. The fact of being calm is not very discriminatory for a user to select between one restaurant or the other. So their weight here in the IDF vector would be lower, which is why we are taking the inverse here after taking the sum, of course, on the old restaurants. So here it's like as if the restaurant was our set of documents, and each term is basically a specific criteria that we listed above. And then we need to compute the TF part, so the term frequency. For each restaurant, basically we are going to, it will be the number of people who voted whether the restaurant is exceptional or not, the number of people who voted whether this restaurant is calm or not out of the 30 people that we polled for each restaurant. And so this is the term frequency. So if out of 30 people, 10 said that the lobster was exceptional, the term frequency would be 10 out of 30. Okay. And then we normalize here by the maximum. So this is still vectorized code. And then we compute the TF-IDF by multiplying TF and IDF. So we do it for the dishes, we do it for the dish presence separately for each of those, because the calculation is different for each category of criteria of feature. And then we concatenate everything, basically. And here you have basically a piece of code to check that this computation is done once every day and then stored as a CSV. Okay, and then quickly for the users, we have the same thing. If we go to the feature and then build user feature for similarity with restaurant, we see the same features that we mentioned. So whether the dish is whether the dish is mentioned by the user as being important or not for them, and whether those dishes will be ranked. So based on this ranking, we will infer whether it is important for them that the dish is exceptional, good, average, or bad, giving it a score. So this score is kind of an hyperparameter um, that we tune to. So depending on what is important for this use case. So it is important that when the dish is exceptional, we push it forward. So we give a very high score for exceptional. And also when the dish is really bad, we give a very low score because it is one of the favorite dish of the user. So if it is bad in that restaurant, we want to penalize it quite a lot. And same for the other criteria. So each time, like kind of adapting the scoring depending on what we want to achieve. Okay, and then we have those two vectors which are then pushed into the database and stored, and every day. So we have a use case here that which is calculate and store user restaurants affinity. Um, so either in Firebase or in a CSV. So basically, it is computing the cosine function so either for the median user and then for all the users. It is doing a map. So we apply the function um, to compute basically these scores for each of the users, and then we push the dictionary into Firebase. So just to show you quickly what it is calling, so it's calling the build affinity with restaurant function, which is here. And as you can see here, build affinity function, we already reused the zones because we want to store those affinity scores are what is going to be used by the app when you open your app. And as I told you before, it is zone based. So we store, so I built this to store everything zone by zone so that when the app is calling for an information into Firebase, sorry, it is calling the information for a specific zone and doesn't have to compute a lot of things. So everything is already stored zone by zone with the affinity score, and I am basically calling somewhere. So I am getting all the features that I need. So basically the features from the user, the most recent features from the restaurant, um, and then I am computing the cosine similarity here, adding some randomness also. And then I am storing these affinities with all the data that I need in objects, which are basically the zones. Yeah, and that's about it for the backend. So here you have quite a few other things like coordinates for the restaurants in order to compute the zones. Um, and well, very different things. Um, I have my configuration files where I can configure basically the size of the zones that I want. Um, and I think that's it. We can stop here, and thank you for having followed up to here. Bye.